on this computer. So it is, what is today? Whatever today's date is, the 19th or something like that, right? Yeah, it's Wednesday, first math class, right? So we're going to talk about essential mathematics today. I'm hoping all of this is review. If it is not review for you, please let me know, but it is really, really basic mathematics, and we're going to cover this at like a warp speed if we can, because this is the basics of math. I want to get more into the more applied stuff and out of the basic stuff. So the essential mathematics, we'll talk about whole numbers, integers, symbols, all the stuff that you see here. Really kind of distill this down to what you need to know, what the requirements are for this course. So whole numbers are obviously positive numbers that are greater than 0. Can't be a fraction, can't be a portion number, can't be a decimal, right? So 1, 2, 3, 4, 5, all those numbers that we've learned, and we learned to count when we were like, you know, whatever, 5, 4, 3, whatever it was. Use whole numbers every day, probably don't think about it, right? We measure our body weight, check our speedometer, medicine dosages, caloric intake, all of that. In medical world, a lot of times when we're dealing with numbers, we're typically dealing with prescriptions and over-the-counter drug labels, right? That tells us how much medication's in the drug. What's the patient's dose? How much are they supposed to take each time? What's their dosage? How much they've taken over their whole condition? What's the strength of the drug? And then what's the expiration of the drugs? Because in reality, you should never take a drug that's expired. I'm just warning you, you shouldn't do that. There's a reason why there's an expiration date on it, except for insulin, and we'll talk about that when we talk about drugs, right? So here we have a common drug that we use in physical therapy. This is dexamethasone. Dexamethasone here is a steroid, right? And it's not the steroid that you think that causes roid rage. This is a steroid that reduces inflammation. So maybe you've got some tennis elbow or golfer's elbow. Dexamethasone can actually help with that. We will use this in physical therapy. In this case, this box here, we have 25 vials that each vial is about 1 milliliter. And in that vial, there's each of those 1 milliliter vials, there's only 4 milligrams of actual dexamethasone. So the rest of it, what's the rest of it? Well, the rest of it's probably just, you know, water and multiple other little pieces that are in it, right? We can see they have sodium phosphate, sodium sulfite, alcohol, right? That's where they put all of the stuff in the injection that gives kids autism. I'm just kidding. That's a joke. It doesn't happen. So every vial of some sort of medication has a small amount of medication in it, but most of those medications are in a suspension or a liquid to be delivered in. So in this case, Dex is used for inflammation. And again, we'll talk more about that when we talk about medications themselves, but this is just kind of looking at what we're looking at when we look at numbers. The difference between a whole number and an integer. Well, the integer now has negative numbers, right? When we talk about subtraction, we're talking about negative numbers. So both plus 13 and negative 13 are integers, but only plus 13 is a whole number. So that integer is where we talked about that number line way back in the day, right? Anything to the right of 0 is a positive, anything to the left of 0 is a negative. And it goes from 0 to infinity, right? Both ways. There's not a end point to our numbers. Just look at some people's income, right? We thought there was an end point to people's income, but then we get somebody like Jeff Bezos. And we definitely have not found the end point of some people's income yet. I found the end point to my income, but not for Jeff Bezos yet. Positive numbers are to the right of 0, negatives are to the left, like I said. We use symbols in mathematics to show relationships, right? Equal sign meaning equal to. The opening to the right of the triangle means greater than. The opening to the left of the triangle is greater than. The opening to the right of the triangle is less than. Then we also add the fun of less than or equal to, greater than or equal to, right? You'll see that a lot if you go to like Disney or Universal Studios. They'll say that, you know, your weight has to be less than or equal to 275 pounds. Or if you're greater than that, you can't ride this ride. Or you have to be at least 5 foot to ride rides, right? That's where we get into these less than or equal tos, right? An adult is greater than or equal to 18, although we could argue that for a while too. These are just talking about mathematics, right? if we have one apple is less than 3 apples, right? But 3 apples is greater than 1 apple. We can also write them out in statements, right? Statements help us make sense of the symbols, and statements are how we read something. So in the case of the bottom here, we have 33, open alligator 21, right? That is literally saying 33 is greater than 21. It helps us make sense of it. $200 bills are less than two $50 bills, although I take both. 100 pennies are equivalent or equal to $1. 12 a.m. is midnight. Those are the way we make sense of mathematics, is when we write stuff out. That's usually where it catches people, is when we do stuff like word problems. Does anyone in here admit they have problems when they see word problems in math? Right? You see those problems and you're like, it's like, Johnny has 8 candy bars. He eats 7 of the candy bars. What does Johnny have left? Johnny has diabetes. That's what Johnny has. Right? That's kind of, those are the problems that you're going to get into. I'm going to use math. One of my jobs in this program is helping you get ready for your boards. Like getting in, and we'll talk about the boards and how the boards work, and actually talk about it in this class, because I'm going to use that math in this class for that. But one of my jobs is getting you prepped for it. And one of the things you're going to find out is all of the questions on the boards are nothing more than complex word problems. Not necessarily math, but they're complex word problems. So if I can teach you how to solve a math word problem, I can help you break down a complex question in physical therapy and hopefully help you pick a good answer, even if you don't know the answer. So you're going to find, as we go through my classes, I'm going to progressively add more and more test taking strategy to you guys, where it helps you start thinking about, oh, okay, so this helps me understand why this is the question and this is not the question. But word problems are always fun, right? It's just the math problems. Why do I need word problems? Just write it out and tell me what I'm supposed to solve. Most of my problems will be that way. Most of my problems will literally say 100 plus 25 equals, and you go down and look in the multiple choice and go, oh, it's 125. There will be some word problems just to challenge you a little bit. Order of operations is important, right? This is how we mess things up quite frequently. And this is the fun that you get on Facebook, right? You can post an order of operations question on Facebook or Twitter or Instagram or whatever other social media you want. And I guarantee if you post some questions on math, you'll get 50,000 different answers from different people, and they're arguing about why their answer is right. There's only one answer that's right in mathematics, and that's one that follows the order of operations. Right? When I grew up, I learned it as PEMDAS. You know, parentheses, exponents, division, multiplication, addition, subtraction. Evidently now the math books more say PEDMAS, the parentheses, exponents, division, multiplication, addition, subtraction. Doesn't matter which way you do it, because multiplication and division, we're going to find out, are just reciprocals of each other. Same thing with addition and subtraction. There's reciprocals of each other. So what does that mean? This means that if you have a question, the first thing you need to look at is, what does this question have in it, and what do I have to do first? That's what order of operations helps us understand. We've all seen, I'm sure, somebody on Facebook posting something like 2 plus 1 in parentheses times 7 plus 4 equals, and then somebody else posts the answer that's the wrong answer. Here's a fancy thing to tell you guys, and I don't know if you know this. You can open up Google and type in any math problem you have, and Google will give you the right answer. I don't know if you know that or not, but Google is a pretty scary machine. Eventually, it will become Skynet and take over our world, and we'll be all living in the Terminator world. But in general, Google does a lot of good stuff for us for searching. Could you imagine what the world would be like if we didn't have Google nowadays? It'd be kind of scary, wouldn't it? Like, we'd all be using Bing. Does anyone actually use Bing? I don't think I've ever actually used Bing. It just makes me laugh when I think about it. Addition is the most basic of our operations. It involves combining one number with another, leads to other operations. When we talk about addition, we are trying to find the sum of the numbers, the sum of the whole, right? So 2 plus 5 equals 7. 2 and 5 are our things we are combining together to get the sum, which is 7. Right? 7 plus 14 equals 21. Addition forms the basis of all that we've done. And if you think about this, like this, the addition goes back to like the golden rule with Pythagoras in Greek times, and even back to ancient Egypt with designing the pyramids. This is some pretty, I mean, advanced stuff for the ancient days, just to even come up with basic mathematics like this. And it's been around for ages. Remember that if you end up with one column adding up to more than 10, you've got to carry it over, right? So in this case, we have 37 plus 25. When we add 7 and 5 together, we get 12. We've got to carry that 1. Now, bonus for you here is, how do you guys solve this? 37 plus 25 equals, and there's the calculator for you. All of your phones probably have calculators on them. If they don't, you can download one. I was really impressed that the iPad doesn't come with an inbuilt or built-in calculator when I first got it. That just seems silly to me that you have to download a calculator. And for those of you that have a Nintendo Switch, just to let you know, last week they released the calculator for the Nintendo Switch, which is something we've all been asking for. It only costs you $10. In physical therapy, we may use this for doing something like distance. Yesterday, your patient walked 75 feet, and today the patient walked 25 feet further. So how far did they walk today? That would be a really common word problem for me. So 75 plus that 25 means the patient walked 100 feet today. Fluid intake. This is going to be one we're going to talk about when the math problems that we do deal with a lot, and subtraction problems we deal with, is fluid intake and fluid outtake, and especially in the hospital world. Patient drank 50 milliliters of coffee, 75 milliliters of water, and 200 milliliters of ETOH. Does anyone know what ETOH is? What that symbol means? Because you may see that on a patient's chart sometime. Does anyone have an idea what ETOH means? Yeah, alcohol, right? A lot of times you'll see in the patient's chart, it'll say ETOH abuse. That means they abuse using alcohol, right? Specifically ethyl alcohol, which is most of what we drink, right? So in this case, the guy drank more alcohol than he drank anything else. Seems relevant for Las Vegas. Yeah, that's about right? Except for me, I'm more of the 50,000 gallons of coffee guy. In math, addition can be checked by performing the next step, subtraction, right? We can back it out and see if our answer is right. You can also check subtraction by reversing it and doing addition. So again, they are ones that work in inverse of each other as well. So subtraction is taking values away from another number. Takes the min from the subtrahend and leads to the answer correct difference. Just to let you guys know, this is not a test question. Don't worry about knowing the names themselves, right? But you need to know that the difference is what's you're looking for here, right? With math, we're looking for the sum. With subtraction, we're looking for the difference. So when doing longhand subtraction, meaning that you're actually writing stuff out, you line the digits up based upon their numbers, the ones, the tens, the hundreds, the thousands, the tenths, the hundredths, the thousands, whatever you have to do, and work your way to the left. So you start on the right, move that way. You will make less mistakes if you work vertical when you're doing handheld mathematics. The number cannot be subtracted from the number above it. You may need to borrow 1 from the column to the left and reduce that number by 1. In the case here, we have 67 minus 23 is 44. Now, I put behind this here what we would call kind of the new math. I don't like new math. I'm not going to teach you new math. I have a godson, and I don't understand new math. I don't care what the reason why 44 is the answer. 44 is just the answer. That's all that matters, right? And so in this case, this is the way they would show you to do this, is that, well, if you subtract 7 from the 3, you get 4. If you subtract 6 from the 2, you get 4. So your answer is 44. That's just way too much work for me. I do most of my problems by rounding, and we'll talk about that. but you could check this just by going in reverse. If I take 44 and add 23 to it, so if I go 44 and I add 23, I should get 67. Right? Or if I subtract 44 from 67, I should get 23. So all those numbers should work in coherence with each other. In physical therapy, looking at our hours of work is one of the reasons we may look at subtraction here, right? If you work 8 hours a day for 4 days straight, but you have a half hour of breaks every day, how many hours are you paid for a day? Well, if you have 8 hours and you subtract a half hour out of it, 8 minus 0.5 is 7.5 hours for paid for each day, right? If you're paid $20 an hour, you'd lose a total of about $10 in that day in unpaid time. That's pretty common. This is why a lot of physical therapy clinics will schedule you for 8.5 hours versus just 8 hours, so that you're getting a full 8 hours of pay, or more, that they're getting full 8 hours of work out of you. Patients taking in 325 milliliters of fluid a day, has vomited up to 15 milliliters, urinated 75 milliliters, and had 200 milliliters of watery stool discharge. How much fluid did your patient retain? Well, in this case, first thing we have to add up is the amount of stuff that went out and subtract that from the amount of stuff that came in, right? So we add up the 15, the 75, and the 200, and we get, well, they had 290 of output. The 325 is our input. So our input minus our output means that they retained about 35 milliliters of fluid. This patient is probably dehydrated, right? Most of us, and I know probably some of you will argue this, but most of us in the world are chronically dehydrated. We don't drink enough water. And a lot of that's going to be a big problem for your patients as well. I have that problem, not chronically dehydrated, but I have that problem where I probably consume a little too much caffeine and not enough straight water. I always joke that my coffee has water in it, but that's not enough. We should be drinking just regular, good old-fashioned H2O, just like Waterboy said. Some high quality H2O. So multiplication. Oh, we all remember these multiplication tables, or at least some of us should. I'm going back here. Scott says it's been 30 years since he's done math and physics. I'm sure Scott remembers these multiplication tables. Some of you may look at this and go, what is this stuff? They used to make us memorize this stuff in school. I don't know if they still do that. For some of you that are younger, did you still have to memorize these multiplication tables? Just curious. Like, we literally had to write these out in school. They still do? Oh my gosh, that's impressive. I didn't think they did that nowadays. I mean, they're taking everything else out of school. I was take multiplication tables out. Good news is I'm not going to make you write a multiplication table out. That has nothing to do with physical therapy, right? Multiplication is nothing more than doing repeated addition, and sometimes a lot of repeated addition, right? You're factorizing numbers. The two parts of the factors, the answer is the product. And back when we rode the magical school bus, again, we had to memorize these tables, right? 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3. And we had to go through all those fun mathematics, right? And we know that 1 times any number is always going to be the number that we're multiplying it by, right? So 1 times a million is a million. What if we multiply something times 0? What happens? The answer is always what? 0. Yeah. Right. So those should be the questions you get on my quiz that you're like, I get that answer, Mr. McKeeva. Right. 100 times 0 is 0. For those of you that don't know, I don't know if you've ever had we'll talk about here in a second with division. I'm going to wait. I've got a good fun fact for that in division. So when you're multiplying, you're simply setting up a long addition problem. Right. So here we have 100 times 12. Right? Well, if we did it longed out, we'd have 1,000 plus 200 or 1,200. There's easier ways to do this. Again, calculator, right? And even if you are one of those people that is neurotic like I am and want to do your math longhand, because I still do my math longhand, it's always good to still check your answer, right? When you're building something, the good phrase is measure twice, cut once, right? Always double check to make sure that you're the way you are. Otherwise, you'll come up short building stuff. Right now, you're not doing a lot of building because I don't know if any of you have seen the prices of building stuff, but I was looking at building a deck at my house in Tucson, and I decided I really don't need a deck right now. Lumber costs are ridiculous right now. They have been multiplied multiple times. I think the deck size I wanted worked out to be like $15,000 with all the lumber. I'm like, yeah, I don't need a deck right now. I'm okay. I'm okay with my little patio. It's fine. Remember, in long multiplication, if the sum is greater than 9, you'll end up carrying it. Same idea with, when we do addition as well. So here in physical therapy clinic bills $95 per therapy session at a flat rate for each patient. Pretty reasonable. Each day, the therapy completes 125 sessions on average. How much is the gross of that clinic in that day? So we have 125 visits, $95 per visit. We're going to multiply those together. And we're going to come up with $11,875 is their gross daily. One thing I want you to remember in a word problem, if there is a question that has a label on it, dollars, Celsius, Fahrenheit, Kelvin, time, AM, PM, make sure that your answer has the label as well. Because if I came down here and if I had this question on the test, my choice A would be 11875 and look like that, where choice B would be 11875 with a dollar sign. Your brain is going to come down here and see this and lock in on that. Yeah, that's the answer. But really, the answer is the one with the dollar sign. I will do a couple of those trick questions with you because that's teaching you to read the answers thoroughly. Because when you get to the boards, there will be at least 2 answers that are really good looking answers. And if you don't read the answers thoroughly, you will get hung up on that. So please make sure if you've got a label in your problem, the answer has that label. Otherwise, it can mess you up. And we've all done that at some point in our schooling, right? Division is the inverse, or what's called the reciprocal of multiplication, in the same manner that addition and subtraction are related. You're splitting a number into parts. The dividend is the number being divided. The number dividing it is the divisor. The answer is the quotient. Again, math terms, not as important to what we're doing, right? Division be shown horizontally, vertically, or with a silly division symbol. I always call it the silly division symbol because I never learned what it was called. And evidently in mathematics, it is the one thing that has no name. This little, I'm going to purple because I like purple. This little thing down here is just called the division symbol. Well, that's called the division symbol. Well, that's called the division symbol. Shouldn't this have its own name? I think this poor thing needs its own name. Right? That's a silly division symbol that I call it there, right? The interesting thing about division, when you have division, if I say something like here, we have 12 divided by 4, if you look at that, that's nothing more than a fraction. That's 12 over 4. So a lot of people get really kind of hung up on fractions when we get to them, but reality, fractions are just division. Fractions are also nothing more than decimals. Right? So all of math is kind of relative, kind of like the area that I was born in Pennsylvania. So 14 divided by 2 is 7. Here we have 3 dividing and 27 equals 9. So what we look at in physical therapy, well, carbohydrates have 4 calories per gram, and your patient is consuming a bowl of soup with 368 calories of carbohydrates. How many grams of carbohydrates have they consumed? Right, so here we have 368 divided by 4, so they've consumed 98 grams of carbohydrates. That could be a good thing if it's something like a complex carbohydrates and we got a patient on a high carb diet to improve their energy, Or that could be really bad if that's 92 grams of sugar, right? And our simple grams of carbohydrates. How many of you guys openly admit that you look at the food labels? Is anyone willing to admit they never look at their food labels? I used to be like that until I got into healthcare. Then I really started looking at my food labels and what's in my food and how many grams of sugar is in everything. And it just terrifies me now. Sodium, especially. Man, sodium, you look at how much sodium's in something. Whew. Let's see. I got a can of Coke Zero here. How many grams of sodium are in this? 40 milligrams of sodium per can. So if I drink 100 of those, I've got enough sodium to last me a lifetime. So if you work in physical therapy and they provide you with 80 hours of paid time off per year, and you're paid 24 times over that year, how many PTO do you earn per payday? Well, in this case, you earn about 3.5 hours per paycheck, or 3.33 repeating, right? So that tells you how many hours you earn. That's a really important one for a lot of people, is calculating how much you're going to earn per paycheck of PTO, because we always want to know when we're ready to take vacation. I will tell you, in physical therapy, it is pretty rare when you get a job to get PTO right off the bat. So paid time off or sick time at all, you usually have to build up your bank. It's not like you get hired and we'll say, well, in 90 days, you have 40 hours of PTO. No, usually you start with no PTO and you have to start building the bank up. I worked in Denmark for 2 years, and it's a totally different system over there. It always amazes me. When I was working in Denmark as a PTA, I got hired and instantly had 6 weeks of vacation per year. 6 weeks. Wouldn't that be nice? Think about that right now. For those of you that are working right now, how much would that be beneficial to you if your boss came in and said, tomorrow we're giving you all 6 weeks of vacation for the year? And you can actually use it. That'd be nice. I don't know. I think sometimes we get a little bit of that'd be the best, right? And I'm going to talk when we're talking about taking a physical therapy job a little bit about how to make sure that you keep an eye on this, because this PTO could be a definite benefit. Right? We all need PTO. If nothing else, this year with COVID and everything else has shown us that we all need a little bit of a brain break, right? If you work constantly, you'll burn yourself out. I'm going to go for about 15 more minutes and let you guys, instead, rather than give you a break, I'm going to go for 15 more minutes and then let you guys out 15 minutes early rather than give you a break. Is that okay? So I'm supposed to give you a 15-minute break for my 90-minute class. I'd rather power through it and just let you out a little bit early. Does that sound fair? See, okay, I never get arguments with that at all. Everyone's like, nope, I'm okay with that. All right, so solving for unknown numbers. So this is where, so for whatever reason, people can do this really easy. What plus 14 equals 78? What minus 3 equals 1? Right, best teacher ever. Exactly. But you know what's funny is if I come in here and change this and say x plus 14 equals 78, solve for x. My handwriting is not the best, sorry. All of a sudden you get freaked out because now I got a variable. But in reality, algebra is nothing more than just solving for an unknown number. Just take the variable out if it freaks you out that much, right? So how would we solve this one? Well, we know that addition and subtraction are the inverse of each other, right? So if we take and go, okay, so if I subtract 14 out of 78, right? Okay, what's that going to give me? 64. Good, right? So 64 plus 14 equals 78. It's just the inverse of it. Exactly. Right? X equals 64. But there is. How many of you guys freak out a little bit when you get to algebra questions? Anyone do that? And we're going to do really basic algebra. So Jasenia and Sean, don't totally freak out. Like, we're not going to do like x squared plus x equals 35. No, we're going to make it simple. I really believe in I believe in the good old phrase KISS. Keep it silly, or keep it simple, silly, right? The simpler we can make it, the better. What minus 1 or what minus 3 equals 1? Well, 4 minus 3 equals 1, right? Because if we add 1 plus 3, we get 4. So this is just solving for the unknown, and it's the basics of algebra. And this is kind of funny. When I was growing up back in the dark ages, when we rode dinosaurs to school, for whatever reason, my first year of algebra back in actually, it wasn't even high school, it was middle school back then. I remember 7th grade, we got Algebra 1. And I failed Algebra 1. And I love math. But for whatever reason, adding that stupid variable in just messed me up. And then I retook it, and I'm like, why was I don't understand. What was going on in my brain that I couldn't grasp this? It's fairly simple when you look at it going, oh, it's just solving for an unknown number. Rounding can help reduce numbers and makes them easier to manage and to use for formula estimations, right? This little squiggly line, again, I forget what the name of this thing is actually. It's the term of equivalent, right? So if I say that 6 is about equivalent to 6.1, that would be true. But 6 would not be equal to 6.1, right? So that's about or approximately. When we round stuff, we use zeros as placeholders, but you need to know what you're rounding to. The ones, tens, the hundreds, the thousands, the tenths, the hundredths, thousands, right? So if I was to say, you have $5.75, and I say round that to the nearest dollar, what would you have about? About $6, right? Yeah. Whereas if I say, round that to the nearest tenth, we'd say you have about 580, right? So you just have to know where you're rounding to, and that's going to come into reading the question. So here we have rounding 1,000 up to the nearest thousands. Well, we look at this and go, okay, this is where we're going to, right? We're going to the 1,000s. The number beside it is a 0, so that means we just make everything a 0. We have 1,000, right? Here, if we're rounding to the nearest 100, the number we're rounding to, I always underline it, is the 1. 9 is our number we're going to use as kind of our guide. If it's greater than 5, we go up. If it's less than 5, we go down. Actually, greater than or equal to 5, we go up. And this is going to come into play when we talk about time cards in a little bit. So rounding 1,192 up to the nearest 100 is 1,200. We round 5 to the nearest 10. The nearest 10 is 10. What if I said round 4 to the nearest 10? Can you do that really? Theoretically, rounding 4 to the nearest 10 would be what? Does anyone know? Yeah, 2 minutes, yeah. Rounding 4 to the nearest 10 technically would be 0. But in math, this would be what we'd call an unsolvable problem. Because we don't have enough to actually round to a 10. Right? There are some problems that will come up as unsolvable, but luckily for you guys, you won't get any of those. Estimations can be used to provide a quick, non-specific answer, right? That is equivalent. When I took my ASVAB, does anyone know what the ASVAB is? Everyone's like, those of you that know what it is are like shaking in your boots thinking about it. Would you agree? It's a fun test, isn't it? Yeah, it's the military entrance exam, right? When I took the ASVAB and I got to my the math questions, I almost never did straight addition or straight math, multiplication. I rounded everything and estimated. Because if you can round and estimate effectively, you can get an answer quick, right? When you do multiple choice questions, one of those answers is going to be close to your estimate. It's the easiest way to do it. It can be used to quickly determine approximates. Here, if we have 2332 plus 2917, we can enter it into our calculator. right? Or I can say that, well, 2332 is close to 23. 2917 is close to 30. So the amount's going to be about $53. Well, the true answer is 5249, which is close to 53. So in a multiple choice question, you have something like, the answer would be like 5190, 5249, 5735, I don't know, and $60. Well, if you do simple math and just do estimations and you came up with $53, you can come down here and go, oh, well, B is close to $53. That's my answer. Wow, that was pretty simple. Right? It saves you a little bit of time. And when it comes to your boards, when we start talking about the boards, and I know the number one question I'm going to get from you guys is there going to be any math questions on my boards? Not likely. And any math question you have, we'll deal with range of motion, and we'll talk how to solve those when we get to range of motion. Those are pretty simple to solve, even if it's a math question. So are you likely to have to calculate money on your national boards for physical therapy? I hope not. They have that on there, I'm concerned. That's not testing your ability to do physical therapy. It's testing your ability to do math. So estimation goes back to that rounding principle, right? So if it's greater than or equal to the midpoint, round up, right? So 50 cents to 99 cents, we round up. For time, it's 30 to 59 minutes, we round up. If it's less than, we round down. This will come into play with our billing pretty heavily, which is why we talk about it. So let's look at an estimation here. Your patient Bob has some higher level executive order deficiencies in his brain. That's basically saying Bob's brain is bad right now. He's probably had a brain injury, traumatic brain injury like a smack to the head, or maybe he's had a stroke. And he's asking you to estimate his expenses in physical therapy for the past 4 months so he can budget for the next 4 months. So you go into the system and you look that his bill was $65.85 for March, $59.10 for May or for April, $62.75 for May, $58.25 for June. You could go and add all of those together and come up with an exact estimate, an exact amount, which came to $2,245.95. Or you could just round all that and say, hey, Bob, you need about $250. Right? I can look at this and go 70, 60, 60, and 60, and it's about $250. That gives him a little bit more than he needs, but it gives him a good estimate. Budgeting like this is really important. For those of you that don't, how many of you guys actually do budgeting? Like for your household? Do you guys actually have a budget? Stephanie says yes. That's actually, I've already gotten like more people saying yes than I've ever gotten before. So I applaud you guys. Must be this new generation, because my generation didn't do that. I'm just saying. I was going to say, right? Yeah. My generation, we weren't so great with budgeting. I'm just saying. Now, I was, because you'll learn really quick. I came from Appalachia in Pennsylvania. And does anyone know what Appalachia is synonymous with? Okay, redneck. Yeah, okay, that too. It's also one of the poorest areas in the country. An avalanche of debt and also an avalanche of opiates, right? And having multiple kids will do that too. You're 100% right, Stephanie. Once you have, actually, let me rephrase that. Once you have your first kid, it starts teaching you to budget. Wouldn't you admit that though, Stephanie? All of a sudden, fun toys go out the window for adults when they have kids. But having a budget is really important. And it's going to be really important for you guys really soon, because I don't know about how many of you guys are, in here with full-on scholarships paid. Maybe some of you are using the GI Bill, so that'll pay for most of your schooling. But a lot of you are going to graduate with student loan debt. And it's really important to get that student loan debt out of the way as soon as possible. You know, I had my student loan debt paid about 2 years. My goal was whenever I finished a degree, within 2 years, I wanted my student loan debt eliminated. So I would work extra hours just to make sure I paid my student loan debt off as soon as possible, because I didn't want that hanging over my head. And it's a lot different, you know, even my generation, the student loan debt was a little bit different than it is now, right? I love it when I hear people that are, you know, the greatest generation or the baby boomers that say, well, why don't you just pay for your college by working? Well, you know, Mom, when you went to school, college was $700 for a semester. Now it's $10,000 a semester. There's a big difference. Interest rates are, yeah, well, no, back when I went through, interest rates were not reasonable. Reaganomics was not good for student loan interest, just to let you know. Student loan interest is a lot more reasonable than it is now. And I think we're going to see some major changes in student loans, the way they work. So hang on to your hats, folks. I think that's going to be the next industry that's going to have to change. That's the next bubble that's going to burst. So we'll talk about that when we talk about finance in here. But that's why we talk about estimations and rounding in physical therapy. We're going to stop here. So I'm going to stop sharing. We're going to start next class on Monday with statistics, because that's the fun one that everyone loves. Was that a fair, pretty basic overview of basic mathematics? Was anyone confused with that? Was that pretty simple? Right? When we get into statistics, it's going to get a little harder. That's why I want to start fresh when your brains aren't mush right now. All right, I'm going to stop recording.